Dear students, in this lecture I shall discuss the problem on graphs and networks. One more situation I will take, and then how to write a matrix to the circuit problem, and then how to solve that, and for calculation of the flows of the currents in particular directions. So I will write a diagram here, and the battery is fixed to the electric circuit, and then how to represent that flow of the current through the circuit in the form of that particular matrix. Later we will study the behavior of the matrix in reference to the rank, and what is the behavior of the current flow through the circuit, that is through edges, once again through edges and nodes. Okay. The circuit diagram is like this for the particular problem. Example, suppose a battery B3 and a current source F2 with 5 resistors connect 4 nodes. Node 4 is grounded. And the potential X4 equal to 0 is fixed. Potential X4 is fixed. The circuit is like this. This is the third edge, and from this node to this node the current is flowing. Here the battery is fixed, this is called B3, and current source is this point. This point is the current source. This is, I am going to represent as X2 according to the data. Then this is X1 and this is X3, and X4 is grounded. Grounded symbol is this, we represent in the electric circuit. This point is grounded, and the current flow from this is called F2. This is called F2. Now this is resistor 1 and the flow of the current in this direction, that is Y1, and flow of the current in this direction, this is Y5 here, and this is R1, this is R2, that is resistor number 1, resistance number 2, and this is R4 I am taking, this is R3, this is given according to the question, and this is Y4, here it is, and this is from X1 to X3, the flow direction from X1 to X3, and this is battery B3. Then here it is current source, it is represented by with this mark, and X4, this is Y5, and R3 this one, then it is Y1. Okay, so this is the node, and this is also the node, this is also the node, and this is also the node. Now we have to find out the incidence matrix for this representation. Incidence matrix, otherwise topology matrix, otherwise connectivity matrix. Okay, so we start from this point. The current is flowing through the resistance 1 and through the resistance, this resistance is 5 I have taken. Okay, resistance 1, and it goes up to resistance 5, then it is resistance 4, from here again resistance 2. So it will come like this, and then the flow of the current with the battery fixed, and this battery line will be from, that is X1 to X3. So what is the incidence matrix for this electrical network, the flow of the current through the circuit. That means where the battery is fixed, the storage of the current will happen. Thereby we consider that as, and the grounding line, that means grounding line at this node it is to be shown. This is called grounding. You can show grounding point, I can call it. So what is the incidence matrix for this? Our observations according to the solution you have to take. So here given that how many resistances? Given that R1, R2, R3, R4 and R5. R5 are the resistances. This is first observation, and second observation, battery, that is B3, battery is 1, that is B3, and current source, that is F2, current source should be EF2, and at X4, this point at X4, that is grounded. At X4 it is grounded. Now, and the adjacent nodes, that means 5 resistors, right? 5 resistors and node 4. Okay, the current source F2 with the 5 resistors means this is also to be taken as an incidence matrix. This is also to be taken as a connectivity matrix with these given numbers. Okay, so the matrix represented for the given circuit with 5 resistors as incidence matrix. Incidence matrix. That incidence matrix will be given like this. That is incidence matrix A, right? That A will be indicated by, for this matrix, that is non-square matrix anyway. The first number, it is 1. According to this equations I will form later. That is 1, 0, minus 1, 0, minus 1, 1, minus 1, 0, 0, 0, 0, 1. This is 1, minus 1 and 0. This is 3 rows, row number 1, row number 2 and row number 3. That is column number 1, column number 2, column number 3, 4 and then column number 5. That is m rows and n columns. That means m cross n is equal to 3 rows and 5 columns. This is the matrix. This is called incidence matrix. Should be 3 cross 5, and these are the edges where the current is flowing with the directed graph, and these are the nodes where the current is current is flowing from the starting point. That is first node, second node, third node, like that. Okay, so there are 4 nodes totally, and 5 edges are there. Therefore 3 cross 5 is the, 3 edges and 5 nodes. Okay, so therefore totally 3 cross 5 means 3 rows and 5 columns, 3 5s are 15. Total elements inside the matrix are 15, 3 5s are 15. Now, so you have to find out the rank of this matrix. You have the options only, that is 2 sets of stages of operation. One is first row on the remaining, second is second row on the third row, first row on the second and third, second row and the third row. Okay, so what is the rank of this, which you have to work out? So rank of A is equal to row of A is equal to number of non-zero rows. Number of non-zero rows in order to calculate the flow of the current through this given circuit with 3 edges and 5 nodes. Now I will solve for the rank of this matrix, whatever the circuit represents. We will follow the row operations. So what is the row operation now? For the first one, these two elements to be taken as 0. This is called pivotal element. So PE, pivotal element. Already an advantage is there. Last row first element is 0 and second row is only 1. Then you have to write that is R1 plus R2 because this is already minus 1. R1 plus R2 is affecting on R2. Then A is equivalent to, first row you will write as it is minus 1 and 0, minus 1 and 0, minus 1, 0 and minus 1. Now the second row, that is R1 plus R2. R1 plus R2 means this is 0, this remains to be minus 1. R1 plus R2, that is minus 1, because minus 1 plus 0 you are writing. Then 0 plus 0 you are going to write it as 0. Minus 1 plus 0 you are going to write it as minus 1. This is the second row, and third row you have to write. So that is 0. Next, and of course there is no operation because already it is 0. Therefore I will write the numbers as they are, 1 1, minus 1 and then 0. So now you have to make this element as 0 with the help of this pivotal element. With the help of this pivotal element, you have to make the second column, that is third element, second column third element as 0. Third element as 0 with this operation R1 plus R2. This is also same thing because already one is minus, another is plus, obviously it gives us 0. Therefore R2 plus R3 affecting on it is R3. Then A is equivalent to the matrix minus 1, 0, minus 1, that is 0, that is minus 1 and 0, this is minus 1, minus 1, 0, it is minus 1 and 0, this is 0, okay, this is 0 and R2 plus R3, this is 0, R2 plus R3 means minus 1 and R2 plus R3 means minus 1. Therefore, the last row is not completely containing all the elements as 0. So we don't call it as it is a 0 row. Implies rank of A is equal to, that is row of A is equal to 3. That implies with the equations, that implies the equations for the incident matrix, incidence matrix A are given by as it is. You have to write the equations minus y1 plus 0 into y2 minus y3 plus 0 into y4 minus y5 and that is equal to 0, first equation. Then y1, next is this is plus 1 and minus 1 minus y2 plus 0 into y3 plus 0 into y4 plus 0 into y5, that is equal to F2. This is the flow of the current in the circuit. Then 0 into y1 minus plus of y2 plus of y3 minus y4 and plus 0 into y5, this is equal to 0. So these are the equations which can represent the flow of the current through the given circuit. So this is what the problem that you can define through matrix equations, and you can find the rank. So you can find the rank means flow of the current you can represent by means of these values y1 up to y5. That means there are totally 4 nodes from all the 4 from at all the 4 sorry 5 nodes. At all the 5 nodes you can represent, that is y1, y2, y3, y4 and y5 respectively. So that is the incidence matrix where the null space for this incidence matrix can be calculated. Now another one last example I will take on this application, that is use of Kirchhoff's law for the conservation of current. The conservation of the current means we can define there is flow in is equal to flow out. Then what is the problem that is going to be given with this? The example is like this: to maximize the flow from the source to the sink then the following figure is shown. That means to maximize the flow from the source to the sink. That means from left hand flow we are going to take, and from right hand sink we have to show. What is the diagram for this representation? It is given in the form of a graph. Now so this is one point, this is another point, this is another point, this is another point, this is another point. Okay, this I will call it as 1 at this point, as source. Then the flow starts from the source and this is the sink. You can take it as 1 and you can write this is a 2, and the direction you can give like this direction, and this also and this also, both are from the source. Then next direction you can give like this, and from 2 to this is 5 and this is 3 and this is 4. Now the edge, of course, this is the direction and this is the direction. Okay, so the edge will be taken as, that should be, I am taking this as edge 1, then this is edge 2, it is given, that is 5, and from here also this is in this direction, and this is 3 given it is 4, this is 5, this is 4, and it is this is 1, this is 1, this is 2, and this is 6, and it is 3, then 4 and 5, this one is 5 and it is 6. Therefore this is the sink. Okay, so from the source up to the sink the flow will be in this direction. This is the direction of the flow. So in between what happens in this diagram, that means this is the source when the flow enters, and this is the sink when the flow is going out. Okay, so in between what is the distribution line? What is the distribution line means, from here to distribution, 2 pipelines we can give. Here to we can call here with respect to the electric circuit, 1 bulb here and 1 bulb here. But again from this bulb you can go for the connection up to the sink from here to here, otherwise from here to here, otherwise from here to here. Then this also can be taken with the same meaning. This can go up to here, this can go up to here, this can go up to here, this is already existing. So this is the pipeline network where from one source you can make a distribution, but it should be in a equal distribution. For example, you cannot put more load on this one particular direction and you can expect the sink to accept. you cannot put more load from another direction, and you cannot expect the sink to be receiving the same load. Therefore, equal load you have to distribute, and equal load you have to continue, and equal load you have to bring up to the sink. But in between, what are the sub connections that you are going to do? It must be in a balanced way. This is called balanced equation. So these lines are representing by means of balanced equation. So then what is the incidence matrix for this? We are going to write in the form of matrix. So this is going to be proved for two applications. One is flow of the current through the circuit. You can use the Kirchhoff law. Kirchhoff law is also the conservation of momentum, conservation law, which is linking with momentum. Then if it is a current, we will have to distribute equally. If it is a fluid, you will have to distribute equally. Therefore, number of ways. For example, you cannot make the negative flow direction from this. That means from this you cannot bring it in the negative direction, so the arrow mark should be like this. From here you have to show the arrow mark like this. You cannot bring it here because source is very near to this. Nodal point, that is 3. Source is very near to this nodal point. You cannot bring this nodal point 4 up to 3. You cannot bring this nodal point from 5 to 2. You have to come from that direction only. That means you are going to make it as a y direction. So from there onwards you can go for the distribution. This is the network. That means flow in is equal to flow out. This represents conservation of momentum, conservation of mass and conservation of momentum. Then what is the incidence matrix for this? But anyway, we can write the solution in this for representing this graph as flow in is equal to flow out. Flow in is equal to flow out. This represents conservation law, you can say. Conservation law holds good. Conservation law holds good. For this, the matrix equation, that is Ax is equal to B, then you can write it as 0. What is the meaning of that actually? Suppose if this is a pipeline, whatever the fluid we are going to allow to flow inside and the fluid is coming outside, if both are same, that means for example 1 liter of water I am allowing to go inside, if I receive the same quantity on the other side, that is the equation. Flow in is equal to flow out. So when the fluid enters into the pipe and fluid is going out of the pipeline network under the reference point, and the measurement, the flow in is the same as flow out, that preserves the conservation law. That is in pipeline network, that is also in Kirchhoff law, it is also hold good. The current flow entering into the circuit, and the flow is current is going out of the circuit for the distribution line, for the distribution purpose. That must be balanced, thereby conservation law holds good. Then for this, the incidence matrix we are going to write for representing the given diagram. This is the given diagram, and the matrix, otherwise we call it as topology matrix, is given by, that is, you can call the general word incidence matrix. A, that is equal to, with diagonal numbers 1, 1, it is -1, -1, this is 1, and then -1 plus -1 here, and I will explain all these numbers, and here 1, then -1 here, and 1, then -1, and then 1 here, -1, and then 1, -1, and next is 1. So incidence matrix is 8 cross 8. Incidence matrix for this given circuit is number of rows will be 6. Number of rows is equal to 6. and number of columns, that is 1, 2, 3, 4, 5, 6, 7, 8, that is columns, number of columns is equal to 6. So what are the rows now? So rows is equal to edges and columns is equal to nodes. So once again, remaining all are 0, you are going to indicate, thereby you can calculate the value of the rank, and then you can see that the flow in each line can be measured by means of after applying the row operation by means of the numerical values. So this is what the problem in the first one, graphs and networks. Only the mathematical background which we can think of to the given circuit, how the matrix can be written in the form of edges and nodes. This is the application of the first situation. Now, so what is the computer graphics? That next application I am going to take it as. In the computer graphics, so we study two situations. One is contraction and another one is stretching. Contraction and stretching, already the introduction I had given in the previous lecture regarding that. So directly I will go to the problem on computer graphics, but computer graphics, the analysis of the pixels, how we can study in 5 different stages, that means 5 different mathematical operations, how we can study. So that part I shall give in a form of some flowchart type. Then I shall take one example related to the geometry, and then how we can stretch and how we can contract with reference to the given factor. So factor of some number it will be given, and to what extent we can stretch. That means we can stretch in x direction, or we can stretch in y direction, or we can stretch in negative x direction, we can stretch in negative y direction. So that what is the meaning of contraction and what is the meaning of that is stretching. Okay, stretching and contraction. So the accuracy in the mathematical calculation, how it is going to happen. If you take a diagram like so many graphs you can expect. One is triangle, next one is ellipse, next one is parabola, next one is hyperbola. So likewise, so many graphs which you can think of. Scissors of Diaconus, next is folium of Descartes, next is asteroid. All these graphs you can represent in the Cartesian coordinate system. Then you can go for the stretching and then contracting. Okay. So in what way this computer graphics can be analyzed? Computer graphics can be analyzed in the form of geometrical diagrams under two conditions, that is stretching and contraction. Okay. So this can be studied in 5 different operations. First one, second one, third one, fourth one and fifth one. What is the first one? First one is scaling and shearing. Scaling and shearing. Second one is reflection. And third one is translation. And next one is rotation. And next one is projection. Because it will go in this order only. Suppose you want to write the flow chart for this. First box. This is nothing but computer graphics. If I represent, that is CG, right? I will write CG. Then it will go for the next box, right? This is called scaling and shearing. And next box, this will go for reflection. It will go for translation. This is the order which you have to think of, translation. And next it will go for projection, rotation. then finally that will go for projection. That means every graph or every image, whatever it is captured in the camera, then it will take first of all scaling and sharing. Maybe whatever the meaning you are going to give when you scan any figure, then you will have to crop it. Then you will have to crop it means according to the required size. So that is nothing but scaling and sharing. And next is reflection. In another word, I can call it as this scaling and sharing. In another word, this one. Here we give the two meanings. That is, scaling means stretching, and shearing means it is contraction. These two are the words. Then reflection. Reflection means what? Reflection is called as mirror image. Mirror image means when I stand in front of the mirror, then my reflection will be seen in the mirror exactly behind the mirror with the same distance. So suppose I maintain from this table to this one as 2 feet. If I want to see the my image or my reflection in the mirror, then behind the mirror it will be 2 feet. Then totally it is 4 feet. 2 plus 2 is 4 feet. This is reflection, means mirror image. You can call another word mirror image. That is nothing but in mathematics, basic mathematics, we call it as a symmetry. Symmetry means symmetry means mirror image. So from the origin up to what distance you take in the positive direction with the same distance in the negative direction. And next, translation. That is, translation means you can think of moving horizontally or vertically. Moving horizontally or vertically. And rotation. What is the meaning rotation? Rotation means you have to rotate from the initial line. Rotate from the initial line means it is nothing but angle. Then you can think of utilization of the angle. Utilization of the angle. And the projection. So projection is nothing but, of course, display. Projection is nothing but display. So here this is all regarding computer graphics theoretical meaning, basic meaning. In detail, too many discussions we will go for it. But when once we take the image scanned, which is the scanned image we take, then it has to be scaled and then it has to be sheared, then it has to be reflected, then it has to be translated, then it has to be rotated, then it is to be finally projected. That means finally the display situation that you are going to consider. Okay, so like this it goes. I will take one example on this as a mathematical problem, how the triangle can be stretched on the x-axis or vertically, that means with respect to y-axis, and horizontally with respect to x-axis. Okay. Example, let T denote the triangle with vertices given by the corresponding matrices, column matrix, that is V1 is equal to 0, 1, comma V2 that is 2, 1, and V3 that is 1, 3, as shown in the figure. That is, in the two-dimensional figure, the triangle is represented in this way. This is x and this is y and this is 0. Now, so this is 1, maximum is 2 and maximum is 3. Okay. So this is 1, this is 2, this is 3, this is 4, this is 5, and here in the y axis and negative x axis, that is -1, -2, -3, -4 and -5. This is +1, +2, +3, +4 and +5. This is -1, -2, -3, -4 and -5. According to the given triangle, so this will be starting from 2 and it goes up to 4. It goes up to 4, but here the length is up to 2 units because it is given as 2. Therefore, it is ended up to 2 only. This is the 2 I am taking, this is 1 up to here and up to here. Okay, then so this is the triangle, which is stretched and contracted, right? Then when it is stretched vertically, that means when you stretch vertically, what happens? When you stretch horizontally, what happens? Horizontally, when you stretch means along the positive x axis. Vertically, when you stretch means along the y axis. Then here the possible questions for this is A. Stretch the triangle, stretch T you can call because it is given as T as the triangle. Stretch T horizontally by a factor of 2. By a factor of 2. By a factor of 2 means from 2 to 3 and up to 4 you can call. Okay. Then question number B, contract T vertically by a factor of 3. By a factor of 3. And the question, stretch T. Of course, let me answer these two first, then I shall go for the another one. Okay. So first question is stretch T horizontally by a factor of 2, contract T vertically by a factor of 3. Horizontally means along the x axis and vertically means along the y axis. Okay. In the solution you can write to stretch T horizontally implies along x axis. Along x axis, that means in this direction. This is the direction which you can give for the first question. Now to contract vertically, this implies along y axis, along the y axis. Then if that is the situation, then the result which you can think of is, because what the factor of 2 and factor of 3. So you can take by 2 units means, of course, stretch T horizontally in this direction. This is answer to the question B. Okay, stretch T horizontally by a factor of 2. By a factor of 2 means this is already 2 is there. Now one more 2 means this is from 2 to 3 and 3 to 4. So this is the boundary you can fix. This is the boundary. That means from keeping this point and then you are stretching towards the positive x axis. And another question is contract T vertically by a factor of 3. Vertically by a factor of 3 means this one already it is 1, 2, there are 2 spacings are there, first spacing and second spacing. Okay, 3 means one spacing you have to make it extra. There are 2 spacings, okay, and that is 3. So 3 means one spacing you have to make it extra for the vertical contracting, and for horizontal stressing 2 spacings you have to give, that is up to 4. Therefore, the diagram which you can expect up to 4 and this will go up to 3, that means 1 contract. So 1 contract by 3. So 1 contract by 3 means that is from 1 here you can represent as 1, this is 2, this is 3 and this is 4 for example, and here I can restrict up to 4, that is 1, this is 2, this is 3 and this is 4. Okay. So now I will start from this point, okay, I will have to go up to this point, that means one spacing here, one spacing I had to consider one spacing from the origin, this is x axis and this is y axis. So stretching by factor of 2, stretching by factor of 2 means totally it is 4, therefore I will go up to 4. This is the first observation, and next observation then it will go up to 2 at the point of 3, therefore this is the point and this is the point. So this is the triangle after stretching and then contracting, after stretching and contracting. This is the triangle, therefore this is stretched towards x axis, contracted along the y axis. So therefore this is up to 4. So this length you can take it as, that is 0 to 4, that means one spacing, that means this is A, this is B, this is C and this is D. Therefore A plus B plus C plus D you can represent. Okay. So now this is up to contracted by a factor of 3. By a factor of 3 means from 1, 2 up to 3 here. Therefore contracted up to 3. So this is the point up to third point, that means third spacing here. Third spacing it will go up to this much. Okay. So then this is the point, this is the point and this is the point. We can call all these 3 points as nodal points. Then therefore the triangle can be stretched like this, okay, towards positive x axis, that is positive x axis, and contracted towards contracted along the line, that is y axis. So this is what the meaning of the computer graphics. One example I have given like this. Then you can think of any graph in this fashion, which is extended along x axis, which can be extended along y axis or contracted along y axis, contracted along x axis, like that. So in any direction the given graph can be stretched. So therefore this can be represented by means of the given vertices. What is the vertices? That means this is the vertex, first vertex, second vertex, third vertex. What are the coordinates of the vertices that will change, then you have to think of. So what are the coordinates here? This is up to x axis, this is 4, you can write it as 4 comma 1. 4 comma 1 means y length is 1 and x length is 4. What is this here? So this, if you represent up to 2, this vertex will be up to x axis it is 2 and up to y axis is 3, you can represent. And what is the coordinates of this vertex? This vertex will be nothing but x height is 1 and y height is 1. Therefore this is nothing but 1 comma 1. These are the 3 vertices where you can think of in order to explain the stretching and then contracting. So this is what the basic meaning in the computer graphics we think. And the last application in this module is the matrices in engineering. So two problems I will try to solve on this matrices in engineering, that is one on basic geometry and another one on electric circuit. So first of all I will take on the first of all I will take on the electric circuit problem, and then I will go for the basic geometry, that is 2-dimensional geometry. Then I will try to conclude the topic on this application of matrices in engineering. Okay. So then the meaning of matrix in the engineering goes for various purposes. One among the purpose is for the flow of the measurement of the flow of the current through the circuit. Next is measurement of the fluid through the pipeline network. Next is measurement of heat flow along the pipeline network when the pipeline is insulated. Likewise, so many applications it will take. Now, so one such problem I will take for the once again circuit problem, matrices in engineering. This is the next application. Directly I will go to an example because already details of matrices we have studied theoretically. Example I will take. Determine the currents. Determine the currents in the network given below. This is the circuit given. Here switch is attached. Here the resistor is attached. Here one more resistor is attached, and the current is flowing from the resistor between two resistors, and here it is one more resistor, this one. Okay, here this is R1 I can call, and you can represent as I1. This is the direction. Then this is the direction. Then these 2 points in the middle we can call it as P and Q. It is given according to the question. This is I2, current 3, and I3, this one you can call. From here I3. Then this is 2 ohms and this is 2 ohms. Then this is 3 ohms. This is 1 ohm and 20 ohms, 2 ohms and 1 ohm and 18 volts. 18 volts. So what are the matrix equations to represent this circuit? Okay. Here the question is to determine the currents. Therefore, equations governing the equations governing the flow of the current in the circuit as 3 important equations you have to specify. Those 3 equations are I1 minus I2 plus I3 equal to 0. The first equation. Second equation, 6I1 plus 2I2 plus 0 I3 is equal to 0. Then 2I1 plus 0 into I2, 3I3 is equal to 18. This is 18 volts. So these are our 3 equations which represent the flow of the current through the circuit. See what we will do here, we will calculate the values of I1, I2, I3 by taking these 3 cross 3 matrix. Okay. Therefore, this represents in the matrix form, we will write that should be AX equal to B. But here the symbols are different. That is A into I is equal to B. Only in place of X, I1, I2, I3, but there we had X, Y, Z. This is the equation. Then you can write these 3 equations. You can write these 3 equations in the matrix form 1, 6, 2, and minus 1, 2, 0, 1, 0, 3. This is I1, I2, I3 in the column matrix is equal to 0, 0, 18. Now you have to solve this. Of course, these three elements according to row operation, you have to make them as 0. You can do that, and already matrix theory we have learned. Too many problems I solved on this. You are getting I1 is minus 1 amperes. This is current is measured in terms of the amperes, and I2 will be 3 amperes. Then I3 is equal to 4 amperes. How you will be getting? That is, these two elements are to be converted as 0, and this is to be converted as 0. Then solve the equations by the back substitution. You will get I1, I2, I3 as flow of the currents. Therefore, three currents values which you can estimate using elementary row operation technique. So with this, I would like to stop the today's lecture, and this is up to the module number 5. It is covered. Only a few samples I have drawn, that means a few samples I have discussed. You can extend for few more problems on this topic after understanding this discussion. Thank you. Let W be the subspace. Let W be the subspace in, that is, region with 4 different values. Here instead of 3, 4 different values spanned by the vectors. There are 3 vectors given. Alpha 1 is equal to 1, 2, 2 and then 1, and alpha 2 is equal to 0, it is 2, 0 and 1, and alpha 3 is equal to, that is minus 2, 0, minus 4 and then 3. Then there are questions like 4 questions. Let me answer the question number C, that means A. Prove that the vectors alpha 1, alpha 2 and alpha 3 form the basis W, form the basis and W linearly independent. Linearly independent. This is first question. And the second question with reference to the same, how this W is a subspace with reference to the given 3 vectors alpha 1, alpha 2, alpha 3, how they are spanned in the region that is totally 4 values, 1, 2, 3, 4 values. And the second question is beta is equal to, that is B1, B2, B3, B4, be a vector in subspace. Be a vector in subspace, that is W. So you can easily make out, you take C1, C2, C3 for this, you can write a linear combination of all these 3. That means you will form a vector, linear combination for all these 4 values, then you will get 4 different equations and you will have to solve for 3 values, that means 3 values of scalars, that means C1, C2, C3. Afterwards you can say that how these they are spanned in the region with the 4 different values. So remaining discussions I will continue in my next lecture. Thank you.